Hello everybody. We're going to take a look at adding and subtracting fractions with different denominators. This is section 2.5b of WAMAP. Question 1 is add 2/9 to 7/12. Okay, so we have to convert one or both of these to have the same denominator. Second question, subtract 4/7 from 8/11. So 8/11 minus 4/7 is equal to what? And we're going to need to find equivalent fractions because whenever we do addition or subtraction anywhere in arithmetic, we have to find like terms so we can subtract them or add them together. Let's take a look at what these look like on the tablet. Okay, so 2/9 plus 7/12. We need to convert these so that they have the same denominator. And what we need to do is find a least common multiple, LCM, that we can use as the denominator for 9 and 12. So when we did this before, we did a super quick prime factorization. 9 factors down into 3 times 3, or 3 squared. And 12 factors down into 2 and 6, and then 2 and 3. So we could write their prime factorizations as 3 squared and 2 squared times 3. And remember, we're thinking buffet, right? And at this buffet, we want to try something of everything. We've heard nothing but good things about this buffet. So we want to try some of everything they got. So they have 2s and 3s, it looks like. But we're going to take the bigger portion of whatever we can find. So I'm seeing this 3 squared and 2 squared. So if we multiply these two together, we will get the least common multiple for 9 and 12. This will be a number that both of them can be divided into evenly. So 3 squared is 9. 2 squared is 4. 4 times 9 is 36. So our least common multiple is 36. What we want to do is multiply the numerator and denominators by the same number that will give us 36 in the denominator of both. So what times 9 is 36? This is where your multiplication table is going to come in very handy. We're going to multiply the top and the bottom of that fraction by 4. And the other one, what times 12 gives 36? Okay, let's write that number in. And we're going to rewrite this expression over here using the new equivalent fractions. So 2 times 4 is 8, and 9 times 4 is 36. So we're going to have 8 over 36. And some of you may notice that those two are both even, so we know these aren't reduced, but we had to change the format so that we could get it the same, it would have the same denominator as 7/12. So let's see what we're adding this to. 7 times 3 and 12 times 3. Over here we've got 21 and 36. So now we've got 8/36 and 21/36 that we're adding together. The units are the same size, so we just add the number. 8 plus 21, that gives us 29. 29 what? 29/36. So that's our answer. And often our answer does not look a lot like what we started with. So 2/9 plus 7/12 is 29/36. Next, we'll take a look at a subtraction problem. 8/11 minus 4/7. So some of you may have noticed that 11 and 7 are both prime. So we don't have to do a prime factorization. They're already done. So we can multiply 7 times 11, and we get 77 as our LCM. So what can we multiply by 11 to get 77? Well, if you've been working on your multiplication table, you know. And on the other side, what can we multiply by 7 to get 77? 11. So we're multiplying the numerator and denominator by the same numbers, and we're going to rewrite this expression over here in an equivalent expression. 8 times 7 is 56. 11 times 7 is 77. And we're subtracting 4 times 11, which is 44, over 7 times 11, which is 77. So we have 56 of these, and we're taking away 44. What do we have left? 12, right? 12 77ths. So if you need to write this up, 56 minus 44, in order to get it right, please do that. Once you practice enough, you'll be able to see those relationships better in your head. 6 minus 4 is 2, and 5 minus 4 is 1. So we get 12 here, and 12 77ths is what we're left with when we take 44 away from 56. Okay, so this is our answer. Let's go back to WAMAP and see what they say. All right, so 2 twelfths plus 7, 2 ninths plus 7 twelfths was 29 36ths. Okay, that one was right, and we fortunately did not have to reduce there. And the next one, 12 77ths. And the factors of 12 are, you could do a prime factorization of 12, and you would get 2 and 2 and 3, right? And if you did a prime factorization of 77, you would get 7 and 11, 2 prime numbers. So they don't have any factors in common, so this is reduced as far as it'll go. These two numbers are coprime. All right, so finding the right denominator for your fractions is going to run you through your paces with the multiplication table. So you might want to have it handy, but it's really a good idea to get those memorized for sure, so that you can save time and get through your problems more quickly. Try a few of these on your own and see how you do. If you get stuck, message.